right, good morning, guys. We're going to go through every chapter. This video is going to be about 6.1. There will be 4 other videos about the rest of the chapters. So let's dive into it. This one is all about understanding our rules for exponents. So if we have the square root of 7, there's also another way that we can write this is 7 to the power of 1 over 2. If there is nothing written over here, there is an assumed 2. If nothing is written over here, there's assumed 1. So this is our basic understanding of it so far. We can also have a question like, we have 64, actually let's just go with 6 to the power of 3 in the 4th root. This would be written as 6 to the power of 3 over 4. So that's kind of our first understanding of it. We can also add on some negatives. If you remember in class, negative is the example, but I will always put my hands up, and that's where we flip. So, if we have 1 over the square root of 125, we can rewrite something like this. Let's say we want the third root. The third root of 25 will be 5. So this will be 5 to the power of 3. We're at 3. But this is also, since it's under 1, it's going to be a negative. So we can rewrite this. And that's just going to be negative. It would be 5 to the power of negative 3 over 3, which is the same as 5 to the power of negative 1. Some other stuff that we're able to do is remove the numbers entirely. We could have this with just letters. We're able to have A3, B4, all to the power of 2. When we do something like this, we have our exponent rule, the power of power. So we will be multiplying that, giving us A to the power of 3 times 2, which is 6, and B to the power of 4 times 2, which is 8. If we take that A to the power of 6, and then B to the power of 8, and if we were to divide it by A to the power of 5, and B to the power of 10, what we're going to do here is subtraction. So we have 6 minus 5, giving us A, 6 minus 5, and B, 8 minus 10. We will have A to the power of 1 and B to the power of negative 2. We are not able to have a negative number at the top, so we will also rewrite this as A over B squared. If we're able to understand this so far, we are in a really good place for success. We can also start having some x's in our equation. We can have, let's do 64 x minus 1 equals 4 x plus 7. I'll pause for a moment. What we're going to be doing here is we see that we have different bases. We can't start adding or subtracting if we have different bases. But there is a way for us to get from 64 to 4. 64 is 4 cubed. Yeah. All of this would be to the power of x minus 1. And that's going to equal our 4x plus 7. When we have an exponent to the exponent, we will multiply. We have 4 to the power of 3x minus 3 equals 4 to the power of x plus 7. Now we can stop worrying about our base numbers. This question has now become 3x minus 3 equals x plus 7. We will add our 3 to both sides and subtract this x. We will get our final answer, or almost, of 2x equals 10, and x will equal 5. All these examples are from the book and from the PowerPoint. I will make sure that the PowerPoint is easily available on Schoology within the same week as the homework or the classwork assignments and the exit tickets with it. So keep your eye out for that. By the time that this is up, that will be out too. And we also, our last big point that we have is that if we have anything to the power of 0, that will equal 1. That is why if we have a to the power of 3 divided by a to the power of 3, that will cancel out. I will write 2 examples from the book that I did not do, or from the PowerPoint. I recommend that you pause the video and try these out. So, number 1, the square root of 15. Try rewriting that. 2. Determine if these are equivalent. To the power of 1 over 3. And 9 to the power of 2 over 3. 3. Let's do m to the power of 2 over n power of -1. And then our last one for these examples, let's do 4 to the power of x over 2 times 4 to the power of x over 5, and have all of that equal 4 to the power of 8. Try these at this time, and let's go through them. Our 15 over here, and I will do this part in green so that you can check your work. Let's have number 1, that will be 15 to the power of 1 over 2. This 81 we can also write as 9 to the power of 2 to the power of 1/3, equaling 9/2/3. When we're multiplying fractions, this will be 9/2/3 equals 9/2/3. So those are in fact equivalent. For 3, we have that negative on the outside. We can deal with that first, giving us our n over m squared. Lastly, our fourth question with all of our 4s. 4 to the power of x over 2. When we have multiplication happening between the numbers, we are going to add our exponents. So we have x over 2 plus x over 5 equals 4 to the power of 8. We're able to get rid of those 4's because we are only dealing with the exponents. X over 2 plus x over 5 equals 8. We should know and not be too scared about these fractions. We can change them to all have the same base root or same denominator. We're here that our 8 is over 1. Our lowest common denominator is going to be 10. So we need to have a 5 to multiply to our x over 2. And for our x over 5, we'll multiply that by 2 over 2. We'll now have our 5x over 10 plus 2x over 10 equals 8 over 1. We are now able to add those together, giving us 7x over 10 equals 8. I will just leave it as that. We're going to multiply the 8 by that 10. And lastly, divided by 7. And we are done. This is going to be everything for 6-1. You can look up a couple more examples of the laws of exponents and rational expressions to get some more practice with this. Again, our test will be on Tuesday, February 9th, or February 10th. So I wish you luck. Enjoy studying and good luck on those classwork assignments.